problems were still on my list: file storage and user sessions. These are the kind of things that look completely fine when your app runs on one server and quietly break the moment you add a second one. So I asked AI to fix both. But this time I didn't just review the code, I actually tested it. Let's start with file storage. Originally, uploaded documents were saved directly on the server's local disk. That works when you have one server. But imagine you add a second server. A user uploads a document to server A. Then the next request goes to server B. Server B has no idea that the file even exists. That's a real problem. So AI changed the architecture. Instead of storing files locally, the app now uses S3 compatible object storage. For local development, I am using MinIO, which behaves like AWS S3 but runs inside Docker. In production, this can be replaced with actual AWS S3. The important part is the application servers no longer own the files. They all connect to the same shared storage. So it doesn't matter which server handles the request. Every instance can access the same documents. The second problem was user sessions. By default, a user's login session can live inside the memory of the server they connected to. That means you log in through server A, then your next request goes to server B. And suddenly server B has no idea who you are. You get logged out. A common solution is Redis. I expected AI to choose that, but it made a different choice. It implemented Spring Session JDBC. Instead of keeping sessions inside each server's memory, sessions are stored in the shared PostgreSQL database. Now every application instance checks the same place, so your login session survives even when requests move between different servers. For this stage of the application, I actually think this was a reasonable decision. It avoids introducing another infrastructure component like Redis while still solving the multi-server session problem. The trade-off is that PostgreSQL now handles session reads and writes. At much larger scale, Redis could become a better fit. But here's the part that matters. I didn't want to just trust the architecture diagram. I spun up 2 application instances behind an Nginx load balancer. Then I tested the actual flow. The login request was handled by one instance. The document upload went through another. Then the download and delete request continued switching between servers. And the user stayed logged in. The files were available everywhere. That's the difference between saying that this should work and proving that it does. While testing this, I also improved something else. The audit trail became much more useful. Before it answered what happened. Now it can answer who did it, where did it come from, and how did they do it. The system now captures the user's real IP address even when traffic captures through the load balancer. And one improvement I really liked, failed actions are logged too. If someone tries to delete a document they don't have permission to delete, the system blocks it. But this attempt itself is still recorded. The delete failed. The evidence remains. For a compliance-focused system, those failed attempts can be just as important as successful actions. And this is probably the biggest lesson from this project. AI can generate the code. It can suggest architectures. It can implement features. But someone still has to understand the trade-offs, test the assumptions, and decide whether the solution actually fits the problem. That's where engineering judgment matters. So now multi-server behavior isn't just a claim. I have actually tested it locally with 2 application instances. Next steps, taking KnowledgeHub beyond my laptop and deploying it to the cloud. Because that's where the next set of real problems appear. Build, review, improve, deploy. Let's see if it survives production.